Hello, you're welcome back. So here we'll be looking at how to write one trigonometric function in terms of the other using the fundamental identities. We saw this earlier for when we're dealing with trigonometric functions of angles, but now of real number, this still holds. If you have cosec t, it's just 1 over sine t, and we have these Pythagorean's identities, which we discussed in the earlier chapters or section. So let's just go straight to example 5. This is saying that if t is in, which quadrant is this? This is quadrant 2. In the second quadrant, you want to write tan t in terms of what? Sine t, right? So what it means that you write tan t, you want to write it in terms of what? Sine t. So it means on the right-hand side, you want everything to be in terms of sine. So we can start with what we know. We know that tan t can be written as sine t over what? Cosine t. And there is a what? There is a fundamental or Pythagorean identity between cosine and sine. We know that sine squared t plus cos squared t is equals to 1, right? Which means we can have that cos squared t is just 1 minus sine squared t. So it means that cos t is going to be plus minus the square root of 1 minus sine squared t, right? So now the question is, what do we take? Do we take the positive or the negative? Now this is where you have to use the quadrant. So t is in which quadrant? Is in quadrant 2. So since t is in quadrant 2, cosine in quadrant 2 is negative. So it means you have to go with negative 1 minus sine squared t. So since we are in the second quadrant, okay? So it means we can write tan t as what? We can write tan t as sine t over minus the square root of 1 minus sine squared t, and we're done. So you can see now we have written tan t in terms of what? In terms of sine t. All right. Okay, next is similar. In this example 6, t is between 180 and 270. So it means this is in quadrant 3, right? So, and what is the assignment here, or the goal here is to write what? Is to write sec in terms of cotan. So let's start with sec. So the question is, do we have any relationship between sec and cotan? No, not really, but we have a relationship between sec and tan. So this is where we're using this identity. We know that tan squared t plus 1 is the same thing as sec squared t. So we can start with that. What do we know? We know this. We know that tan squared t plus 1 is what? Is sec squared t. So it means that sec square, right? So it means from here that sec t is going to be plus minus, right? The root of tan squared t plus 1, all right? So now we have to use the quadrant. So we have sec t is going to be plus minus. I'm just writing from here directly. This is tan squared t plus 1. But since we are in the third quadrant, we know that sec is what? Is negative. So we are still going to go with negative, right? So it means we can delete and go with the negative. And this is because of what? We're in quadrant number 3. And in quadrant number 3, we know that sec is going to be negative, right? Okay, so now we continue. We can write this as this one. But we want to write it in terms of cotan. So we have to change tan to cotan. This is going to be 1 over cotan squared t plus 1. So what have I done? We just changed tan squared t. Tan, we know that tan t is what? Is 1 over what? Cotan t. So that is what we use here. All right. So this is going to be minus this one. We can write this as 1 plus cotan squared t, everything divided by cotan squared t, right? This we can simplify both sides. We can write this as 1 plus cot squared t over, now in the denominator is going to be absolute value of cotan of t. Why? Because you have a square here and you have a square root. So it becomes absolute value. But we know we are in the third quadrant. So in the third quadrant, cotan is positive, right? Cotan is positive. So it means this is going to be positive. And since it's positive, we can remove the what? We can remove the absolute value. We can remove the absolute value. So this is just going to be minus, okay, let me write it here. It's just minus 1 plus cotan squared t. Here now you remove the absolute value and we can just write cotan of t. So this is the final answer. Okay. And this is positive because of what's the third quadrant. Okay. Now this means that tan squared t is just going to be 1 over cot squared t. Right. Now, finally, number 7. This says that what? Cotan theta is equals to m, and you have theta to be in which quadrant? In the quadrant number 3. So now we want to write cosine theta. So all we need to do is you need to write cosine to be in terms of cot. Then anywhere you see cotan, then you can just write it as what? As you can write it as m. So we need to think, how do we connect them? But we know that cosine theta is 1 over what? Sec theta, right? And we know that there is a relationship between sec and tan, right? Or another thing we can do here, since cotan theta is equals to m, what does that mean? It means that tan theta is going to be what? 1 over m. You see that? Yes, this is true. So now I can write this as 1 over, but this is going to be plus minus tan squared theta. Don't worry, we will see which one is better. Are we going to use the plus or minus? Now, since we are in which quadrants? This is quadrant 3. Since we're in quadrant 3, we know that sec is what? Is negative. So we're going to use negative here. Since we are in quadrant 3, this means quadrant 3. Right? All right. So now this is going to be 1 over minus, but tan, we already know that tan theta is 1 over m. What does this mean? This means that tan squared theta is going to be 1 over m squared. So this will be 1 over m squared plus what? Plus 1. And this is just 1 over. This minus is still outside. Here we can write it as 1 plus m squared, everything over m squared. Okay. So similar to what we did earlier, this will just be 1 over minus. Now this is going to be what? 1 plus m squared. I'm just separating the roots now. Now this will be absolute value of what? Of m, right? Now, why are we using? All right, now we have absolute value of m. So let's see now, what can we say about the m? Is m positive or negative? But since we are in the third quadrant and we have cotan is equals to m, because cotan is positive, it means m has to be positive, right? So m is positive. And now since m is positive, it means we can remove it. We can just take it down like that. So we can do away with it. So here, this will just be the same as minus 1 over. We can take the minus up, it's okay. Then this will be 1 plus m squared all over m, right? And now this we can just reciprocal. This will be minus m over 1 plus m squared, right? And then we can multiply by, we can rationalize. So once we rationalize, this will just become minus m root of 1 plus m squared. Then we divide by 1 plus m squared. Yes. So that is the solution here. All right, so this is how to write one trigonometric function in terms of the other using the Pythagoras identity as well as the reciprocal identity. All right, so I hope this is clear. We'll see more of these questions in the exercise. Thank you for watching, and if you benefit from it, share with your friends, and do not forget to subscribe and like this video as well. If you have any question, just put it in the comment section. Thank you for watching.